All right, let's dive right into this explainer and demystify exactly how software is built efficiently behind the scenes. If you've ever wondered how developers manage to create these massive, complex apps without totally losing their minds, well, you are in the right place. We're going to explore the architecture of efficiency and code reuse, and we'll break the whole thing down so it makes perfect sense, even if you're a complete beginner to the world of programming. Here's our roadmap for today. We'll be looking at the repetitive coding problem, building blocks and reusing code, modules versus libraries, a step-by-step look at importing code, how big companies build software, and finally, why modular code wins.
The problem with repetitive coding.
Okay, just imagine having to write the exact same code totally from scratch every single day. Sounds absolutely exhausting, right? Think about having to reinvent the wheel every single time you want to build a car. In programming terms, that would be like rewriting a complex login system, or maybe a secure file handler from the very beginning every time you start a new project. It's tedious, it's slow, and honestly, it's just a terrible way to work. So the core philosophy of modern software development is pretty simple. Stop rewriting and start reusing. This exhausting repetition we just talked about, it's exactly why programmers rely on specific tools to avoid repeating those mind-numbing tasks. They want to spend their time creating cool, innovative new features, not rebuilding the basic foundational plumbing that has already been perfected a million times before. Moving on to Section 2, building blocks and reusing code. Code reuse literally just means using existing code again instead of rewriting the same logic over and over. Think of it exactly like using those plastic building blocks we all played with as kids. When you're building a toy castle, you don't go and manufacture the raw plastic blocks yourself, right? No way. You just grab the pre-made blocks and snap them together to build something unique. Well, code reuse works in the exact same way. Instead of rebuilding common features from scratch, developers simply grab the pre-built blocks. Things like login systems, calculators, database connectors, and sorting functions, these are all prime examples. Once a developer writes a rock-solid database connector, they save it. The next time they need one, they don't rewrite it. They just plug that identical, tested code right into their new project. Section 3, modules versus libraries explained. First step is the module. Basically, a module is just a file that contains reusable code, stuff like functions, classes, variables, and logic. The absolutely crucial point here is that a module helps organize programs into smaller, highly manageable parts to give you much better clarity. So instead of having one massive, chaotic text document with a million lines of code, you have neat, perfectly categorized files. To make this super simple to picture, think of a module as a single recipe card for making a specific dish, like a card that only tells you how to make chocolate chip cookies. A library, on the other hand, is the entire cookbook full of related recipes for a whole genre of tasks. So a library is basically just a collection of these modules, bundled together to give you a massive, ready-to-use toolkit. All right, Section 4, a step-by-step look at importing code. The actual process of doing this is beautifully simple. Step 1 is simply to create the module file where your original useful code lives. Step 2 is naming and saving it, maybe as a Python file on your computer. And step 3, this is the magic moment, is where you use the import command in your new project. You literally just type import followed by the file name, and instantly all that functionality is injected into your current work. It makes it incredibly simple to write the code once, save it, and just pull it into any other file whenever you might need it. Section 5. How big companies actually build software. Now, what's really fascinating is that this isn't just beginner stuff. This is the exact same logic used daily at the highest levels of tech. Professional developers at massive companies like Google, Microsoft, and Meta rely completely on these reusable modules and libraries to build their large applications efficiently. Honestly, if they didn't use this architecture of efficiency, their massive applications would literally collapse under the sheer weight and chaos of their own code. And that brings us to Section 6, why modular code wins. Think about trying to find an error in a massive monolithic code base, which is basically when you dump everything into one huge file. It's like finding a needle in a haystack. It takes forever. But modular code turns that haystack into clearly labeled, easily manageable little boxes, heavily reducing the time you spend debugging errors. If the login screen breaks, you don't have to read through the entire application. You just open up the login module box, fix it, and you're good to go. By snapping together these reusable pieces, developers unlock some incredible benefits.
It saves a massive amount of time, reduces effort, lowers development costs, and completely slashes debugging time. Plus, reusing code that has already been tested means you introduce far fewer bugs, making the entire project way smoother from start to finish.
So, wrapping up this explainer, the crucial takeaway I want to leave you with is a question. If the biggest tech giants in the world use pre-built blocks to save time, why should you ever code from scratch again? Programming is really less about constantly inventing from zero and far more about efficiently assembling the right pieces. So the next time you use an app, don't think of it as one giant mountain of code. Think of it as a brilliant assembly of simple, reusable blocks. Keep that in mind and keep exploring.
If you enjoyed this video and learned something new, like this video, comment your favorite programming language, subscribe to Future Break Coder, because many exciting coding and futuristic tech videos are coming soon.